Factorial. In this section, I will talk about the factorial. Factorial notation. The factorial of a non-negative number n, denoted by n exclamation mark, which we read n factorial, is the product of all positive integers less than or equal to n. N factorial is equal to 1 times 2 times 3 times 4 times, and I can keep going, times 5 times 6 and so on until n. N is the last number in that product. That means that's the definition of n factorial. And of course, if this is n, one number before is the number 1 less, which is n minus 1. And if I want to put 2 number less, n minus 2, n minus 3, and so on. Yeah, just in case for the general notation. And now we have, for example, 1 factorial, it's equal to 1 because it's 1 times itself or just 1. Let's leave the 0 factorial for now. We will define this in a minute. 2 factorial, it's 1 times 2, 2. 3 factorial is 1 times 2 times 3, 6. 4 factorial, 1 times 2 times 3 times 4, 24. And 5 factorial, for example, 1 times 2 times 3 times 4 times 5. That means that's 120. And we probably notice that this grows really fast. Okay? That means the factorial expression grows really fast. For example, I have 10 factorial, and we can see is the 7-digit number. Okay? That means it's growing a lot. Only 10 numbers along the input along the x-axis, if I would like to say this way, and the value, the output is quite high. Okay, that means we have to define 0 factorial. Let's see how can we prove what actually number is this. You probably know, watching this, you probably know what is 0 factorial, but let's try to get this number instead of just giving. That's what we notice. Let's maybe take 4 factorial. Okay, that means 4 factorial, we can see it's 1 times 2 times 3 and times 4. That means I can rewrite as a 3 factorial times 4. Okay, because 3 factorial is the product and up to 3 only, and then times 4. And that means that's quite, and that's the same way. Or possibly I can even write 4 factorial as a 2 factorial. That means I decrease the number by 2, and then I have to finish my product, times 3 times 4. Okay? That means sometimes, in order to simplify factorial expression, we will use this notation. Okay, that means now what I can do, I can try to do the general notation. That means n factorial is simply n minus 1 factorial times n, because that's the same thing. 4 factorial, it's 1 number less factorial, which is 3 factorial times 4. Then n factorial will be n minus 1 factorial times n. Okay. And now, that's quite important. What I will do in this definition of this expression, I will let n to be 1. That means, let's see what I have. 1 factorial equals to 1 minus 1 and times 1. 1 factorial, 0 factorial times 1. 1 factorial is 1. 0 factorial times 1 is just 0 factorial. That means 0 factorial is 1. Right? It's nice proof. So now I can place 1 in my empty spot. So this is the proof of 0 factorial. So 0 factorial is just 1. We can also, we have different thinking about probability. Factorial are used for some permutations. That means we also have different proof, but this is one of the proof, okay, of the 0 factorial. Okay, that means now I have a few expressions that I would like to simplify with you, and by doing this, we will practice factorials. Okay. Okay, on this page, we do have 7 of them. Ask me, how can we evaluate or simplify factorial expression? Means that we have to eliminate factorials. That we have to cancel out the factorials. Would be nice to leave the expression without the factorial. Okay, that means this one is 8 factorial, actually, 7 factorial. And I have to look at the bigger number in this case, because 8 factorial I can define as a 7 factorial times 8. This is gone, it's just 8. Okay. Now again, I will leave the lower number for factorial. I will look at the bigger value, 6. 6 I can rewrite as a 4 factorial, and then I have to finish times 5 times 6. And then again, 5 times 6, I think it's 30. Okay, now let's leave the lower value, 7 factorial, and let's rewrite 10 factorials. I have to subtract 3. That means I will have 7 factorial, and then I have to fill in up to 10. Times 8, times 9, times 10. Okay, and I can cancel out, and I can leave it like that. Maybe I can multiply. 8 times 9 is 72, and times 10. 720 in the denominator. Okay, not bad. Okay, now, I have lots of factorials. That means, let's see. 2 and 3, possibly I can kind of combine and simplify, and 5 and 7. Oh, different way too, but I will do this way. That means I will leave 2 factorial, and I will leave 5 factorial. 3 factorial I can rewrite as a 2 factorial times 3. 7 factorial I can rewrite as a 5 factorial times 6 times 7. And now that's gone, and I have 6 times 7 over 3, 2 times 7, 14, because I also simplify 6 and 3. I could multiply 6 times 7 and divide by 3, but I think simplifying before is easier. Okay, that means that's these problems. Oh, I think I didn't go in the order, doesn't matter. I can do 2, 4, and 6, okay? Because they are actually relevant. 2 is relevant to 1, 4 is relevant to 3. But since we have numerical practice, let's do the general formula. Okay, how can I simplify n factorial over n minus 1 factorial? That means I see that n minus 1 is the smaller number. Let's leave it. And then n, I can subtract 1, and then is n factorial times n. I can possibly use different color, and it's just n. And as we can see, just 8. That's the corresponding question to number 1. Okay, now 4 will be corresponding to 3, because we do have number 2 less. This means what I will do, I will leave the smaller value, okay? And then n factorial, I will rewrite as n minus 2 factorial, and then I have to fill out n minus 1 times n. And then I can simplify, okay? And this is the answer, n minus 1 times n, which that was 5 times 6, also respectively the same thing. n minus 1, okay? And this one is the same thing, because this was 7, and that's 10. n and n plus 3, 3 more. That means now this number is smaller. I will leave this one. And I have to rewrite this as having an n factorial in the expression. That means I will decrease this number by 3, which this means n plus 3 minus 3 will give me n factorial. And then I have to fill out the numbers, the positive integers up to n plus 3. n plus 1, n plus 2, and n plus 3. Again, respectively, like 10 factorial. I subtract 3, which I have 7 factorial, and then times 8, times 9, times 10. Okay, and I can simplify, and I will not rewrite, but that will be my final answer. Of course, without the factorial. Okay, that's 7 questions on this side. Now I have additional 4. Let's look at this one. For the given sequence, a sub n is defined as a 2 to the n over n factorial. Find and simplify the ratio a sub n plus 1 over a sub n. Okay, that's what we have. We do have a sub n, 2 to the n factorial. Now let's define the next term in the sequence, which means instead of n in the formula, I have to put n plus 1. 2 to the power of n plus 1, n plus 1 factorial. One more step. 2 to the power of n plus 1 means 2 to the power of n times 2 to the power of 1. Okay, just, or maybe I can put this in the fraction. Okay, that means I do have 2 terms, and now I would like to simplify this expression. Okay, a sub n plus 1 is 2 to the n plus 1 over n plus 1 factorial, and a sub n is 2 to the n over n factorial. Okay. Dividing by fraction means multiplying by the reciprocal. And now I can possibly rewrite 2 to the n plus 1 is 2 to the n times 2 to the 1 over n plus 1 factorial times the reciprocal, n factorial 2 to the n. That means one thing that I can simplify right away is 2 to the n. Really nice. And what I have 2 n factorial, and in the denominator, I only have n plus 1 factorial. But this number, this factorial, is bigger than n. Then I will rewrite the bigger value. N plus 1 factorial, I will rewrite as one number less, which is n factorial, and times the last number, n plus 1. That means n plus 1 factorial is equal to n factorial times n plus 1. Okay, and now that was the point. I'm simplifying, and my final answer is 2 over n plus 1. Okay? And possibly I can find the limit, or I can do different things with this expression, because it's nice and clear without factorials, without even the original exponential function. This is the final answer. Okay? Another question. The same ratio, but a different sequence. For the given sequence, a sub n equals to n squared times 5 to the n, 2n factorial. Right? That means 2n factorial. Find and simplify the ratio a sub n plus 1 over a sub n. Okay. It's the same thing. A sub n is the given formula, n squared 5 to the n, 2n factorial. That means 2n factorial. If I would like to put n the positive integers, that means I will have 2 factorials, and then 4 factorials, and then 6 factorials will be just the even numbers. Okay? Now let's define the next term of the sequence, a sub n plus 1. That means instead of n, I'm putting n plus 1. N plus 1 squared, 5 to the power of n plus 1. And then now we have to be really careful. N was multiplied by 2. Now n plus 1 is multiplied by 2. Okay? N plus 1 is multiplied by 2. And I have to distribute that to 2n plus 2. It's a little bit different. Okay, but let's create a ratio. It means my ratio, a sub n plus 1 over a sub n. I will copy a sub n plus 1, and I will divide by a sub n. But dividing by fraction means multiplying by reciprocal. Okay? That means I can copy this way, a sub n plus 1 times the reciprocal. Okay? Let's copy. N plus 1 squared. 5 to the power of n times 5 to the power of 1, and then 2n plus 2 factorial. Please note that 2. Okay? I did distribute 2 times n, 2 times 1. Okay, times the reciprocal. 2n factorial, n squared, 5 to the n. Okay. One thing that we can simplify again is our exponential part. And what we have, let's try to simplify. We have n plus 1 squared, and maybe I can put n squared. And I have 2n factorial, and now I have 2n plus 2. That means this number is 2 more than 2n. Okay? That means I can subtract 2, which will be 2n factorial, and then I can add 1, and I can add 2, which means I'm satisfying the definition of the factorial. And I have the same factorial. I can cancel out. I mean, I'm canceling out because that's the point. And I believe I don't have any more simplification. I will have just n plus 1 squared, n squared, 2n plus 1, 2n plus 2. That means again, it's quite long expression, but it's nice and clear in terms of limit, in terms of other things, like if we would like to apply, for example. Okay, that means it's nice expression. Okay, and another one. The same thing, different sequence. For the given sequence, a sub n equals to n factorial over n squared, n minus 2 factorial, find and simplify the same ratio. A sub n plus 1 over a sub n. Okay, that means a sub n is equal to n factorial, n squared, n minus 2 factorial. Okay, which I believe we can simplify this right away. Okay, because we have n factorial and n minus 2. That means let's maybe try to simplify this, and then we can create the next term. This term, which number is less, n or n minus 2? I think n minus 2. That's we always leaving the smaller value of the factorial, n minus 2. And this one, n factorial, I can subtract 2. Okay? That means I get back 2 numbers in front. That means n minus 2 factorial, n minus 1 factorial, and n. That means I do have all of the numbers. Hey, really nice. Oh, actually, I can simplify, and I can even simplify one of the n's. Oh, that's we don't even have factorial. I think it's nice and easy because we only have n minus 1 over n. Okay, but let's try to get n plus 1. We'll just finish this. Let me double check. I end up with n minus 1 and just n. Okay, that means n plus 1 will be, instead of n, I have to put n plus 1, and that was minus 1. And instead of n, n plus 1. N plus 1 minus 1 is just n plus 1. Okay, interesting. That means my ratio, a sub n plus 1 over a sub n is n plus 1 over n minus 1 over n. N plus 1 times the reciprocal n minus 1. N times n is n squared. N plus 1 times n minus 1 is n squared minus 1. Okay, also nice expression without the factorial. And we actually didn't have factorial at all because I managed to simplify the original sequence. Okay, and I believe I do have one more. Okay, for the given sequence a sub n defined as a n to the power of n over n factorial, Find and simplify the ratio a sub n plus 1 over a sub n. That's what we have. We do have a sub n defined as n to the n over n factorial. Then my next term will be instead of n plus 1, instead of n plus 1. N factorial, n plus 1 factorial. Okay, and let's flip the number. A sub n plus 1 over a sub n, it will be the same thing, a sub n plus 1 times the reciprocal of a sub n. That means I will copy this n plus 1 to the power of n times n plus 1 to the power of 1. And this is n plus 1 factorial for now, times the reciprocal, n factorial, n to the n. Okay, I can't really simplify things at the moment, but let's see. I will copy n plus 1 to the n. I will copy n plus 1 to the 1. And now the factorials. N factorial and n plus 1. N plus 1 is bigger. That means I will leave n factorial on the top. Okay? And n plus 1 factorial, I will rewrite as n factorial times n plus 1. And I still have n to the n. Let me save space. Okay, and then this is gone. That's what we need. And additional factor. That means I have n plus 1 to the n over n to the n. I can rewrite as a one fraction n plus 1 over n to the power of n. And I can also rewrite as a 1 plus 1 over n to the n. And I believe we do recognize this expression, but that's not the topic. I will leave it like that. Okay? Because we know what this means, especially if n is infinity. Thank you.